Wolfspeed, a Cree company, is the global authority in wide bandgap semiconductor technologies and an industry leader in field-tested GaN-on-SiC RF solutions, with portfolios of GaN HAPs and MMIC power amplifiers for telecom, radar, and SATCOM.
Welcome to WDD's HotSpot, sponsored by Wolfspeed. I'm Mike Luciano, Associate Editor, and in this week's episode we have Grip and Grab Like a Gecko, Material allows robots to move with light, and solar-powered autonomous aircraft completes its first test flight. The Special Robotic Gripper allows you to latch onto items with different surfaces regardless of shape, texture, or composition. The Special Robotic Gripper was inspired by the Gecko and uses a combination of what's described as Gecko adhesives along with standard robotic grippers. We've seen both of these components applied to different tools and products in the past, but never in the same device. The Gecko adhesive has been in development by NASA's Jet Propulsion Lab for a few years, which isn't sticky to the touch, but still delivers the same effect. Geckos are touted as some of nature's best climbers due to millions of microscopic hairs that line the bottoms of their feet and appendages. These hairs let geckos interact with surfaces on the atomic level so they can grip just about anything. NASA mimicked the gecko by putting microscopic fingers on their adhesive that enables them to grab onto flat surfaces. Researchers at UC San Diego say individually soft robotic grippers have trouble picking up certain objects, like a large cylindrical pipe, while the Gecko adhesive has trouble sticking to objects that aren't flat. The new gripper has no issues picking up objects, especially ones without a flat surface like pipes, rocks, or a variety of other objects of different sizes.
Engineers from the University of Hong Kong have developed a new actuating material called nickel hydroxide oxyhydroxide that can be powered by a visible light, electricity, and other stimuli. Light-induced actuating materials are highly desirable because they enable wireless operation of robots. This material can be used to replace traditional bulky actuators, including motors, pneumatic actuators in micro and biomimetic robots, artificial muscles, and other medical devices. It can be instantaneously triggered by visible light to exert a force equivalent to 3,000 times of its own weight. This new material system can also be actuated by electricity, enabling it to be integrated into present well-developed robot technology. It is also responsive to heat and humidity changes so that they may potentially be applied in autonomous machines that harness the tiny energy change in the environment. Since the major component is nickel, the material cost is low at 4 Hong Kong dollars per square centimeter. It can also be easily fabricated within 3 hours.
High-altitude pseudo-satellites, or HAPs for short, are a type of unmanned aerial vehicle that can soar for long stretches of time and are commonly powered by solar energy. HAPs designs aren't new, considering Airbus and Facebook have already flown a few prototypes over the past few years. Now, Silicon Valley-based company UAVOS has just finished the first flight test of its HAPs prototype, dubbed APUS Duo. The recent tests were performed at the Exponential 2018 expedition. In addition to autonomy and solar power generation, the aircraft CPU supports flexible wings that totaled more than 1,000 flight hours. The test flights took place at an altitude of 66 feet and handled turbulence thanks to the bendable wing structures. Long continuous monitoring for military and non-military applications is ideal for these machines. With that in mind, potential applications include video surveillance, drone communication, and jamming.
The radar, sir. It appears to be jammed.
That's all for this week's episode. Be sure to check in on Facebook and Twitter and catch past episodes at wirelessdesignmag.com. For the WDD channel, I'm Jennifer De La Osa. Thanks for watching.